This is absolutely mind-blowing. Terrance Howard invites you to question the very foundations of mathematics and how they relate to our understanding of the natural world. It's real, powerful, and transformative. So sit tight and let's dive in.
Do you guys know about loops in math? Do you know the square root of 2? Do you think that's a loop? Do you believe that the square root of 2 is the square root of 2? I want y'all to take out your phone for a minute. We're going to do one thing. Put it on the calculator and turn it to the side. Now I want you to put in 2 and square root it. You'll get 1.414213562373095 ... right? Now I want you guys to do me a favor, cube it. It'll see right over there, it'll be x to the 3. It'll see 2.828427121746190. Now that makes sense. I want you guys to do me a favor, divide it by 2. Get that number? Cube it again, divide it by 2, cube it again, and I want you to do that until the end of your lives. And that number will still come up with 2.828427121746190. Any other number that you, above 2, that you put in and you cube and you square, cube and square and divide by 2, by the 6th operation, it has moved into an exponential number that you can't even imagine. Any number below 2 that you do that same operation with, it will go into an exponentially small matter and number. This is what we call a loop. It is illogical, it doesn't make sense, and it does not make math make sense. So these are some things that I'm bringing to the fore and that I would like to question, I would like to audit. If I said to you, what's 1 times 1? What'd you say, 1? It equals 1? Now, what would Newton say is that? Action times an action. That's a reaction, right? Anybody in here that thinks 1 times 1 equals 1, then you give me 2 pounds and I'll give you a pound back. And we'll call that even, right? Because 1 times 1 equals 1. An unbalanced equation. What we need to do is, the first thing in math is you're supposed to have a balanced equation. 1 times 1 equaling 1 is an unbalanced equation. But the identity element, which is like the Jim Crow laws of the 60s, they say that anything multiplied by 1 becomes that same number as itself. Well, the laws of physics has to break down in order for that to take place. Action and reaction for 1 times 1 to equal 1. In comparison to if I said, what's a dollar times a dollar? Anybody know what's a dollar? What's a dime times a dime, or 10 pence? 10 pence times 10 pence, that's a pound, right? What about 100 pence times 100 pence? That's pound times a pound, right? That's $100, ain't it? What about a quarter? What about 4 quarters times 4 quarters? That's $1, right? That's a pound, right? Well, that's $4. Now, all of these things are legal. The banks can say $1 times $1 is $1 and give you that. Or the banks can say to a friend, $1 times $1 is a quarter times a quarter. It's 4 quarters times 4 quarters, and give that person $4. They can say to another person, $1 times $1 is 100 pence times 100 pence. That person gets $100, so that money is generated. And this is all legal. Do you think it's not happening in the banks? This is what 1 times 1 equaling 1 has got us. This inconsistency of our monies and our economy is sitting in the balance. And the rest of our future is sitting in the balance because our science has been stunted as a result of the problems in mathematics, because math asks for the basic laws of physics to break down in order for 1 times 1 to equal 1. In order for 1 times 0 to equal nothing, laws of conservation of energy has to disappear. The foundating laws of math are supposed to support the laws of physics. They are arm in arm. They cannot be in controversy with each other. So we need an audit on the Platonic solids, we need an audit on the square root of 2, and we need an audit on action and reaction, or we either got to get rid of, we say 1 times 1 equals 1 and there's no action and reaction. One or the other, you can't have both. And until we make that change, we're in trouble. Be stunted as a species. The identity principle, the identity property, it says that 1 times nothing equals nothing. So now you have the laws of physics have to now adjust because something just disappeared. Conservation of energy, energy can't be created or destroyed. So if 1 times 0 equals 0, then what happened to the energy of the 1? Isn't that the same problem that Stephen Hawking were talking about with the event horizon and the information going in and still being present? That conflict that was started? Well, that's because of the math. The principles in the math are not founded on truth. It's not founded on substance. The identity principle, anything times 0 is 0, and anything times 1 is 1. Where is that number? Where is that exemplified in nature or in universal phenomena? You know what's interesting? In 1856, a man from Liverpool named Richard Dover Statter challenged the Dewey Decimal System and said that it was wrong, and created an entirely new system to show how it can be brought into correction. So I'm not the first person to state this. It's a number of people did it, but look up Richard Dover Statter. Try and find him. You won't find him because he's been erased from history almost. Our planet is moving away from our sun at 6 inches a year. You guys know that. 15 centimeters a year, our planet is pushing away from the sun. So in less than 500 million years, our planet will be out of the Goldilocks zone. We'll be somewhere near where Mars is, somewhere halfway between there. So life will not be able to be sustained on this planet anymore. So if we're going to be able to sustain ourselves as a species, we have to become interstellar. Not just interplanetary, you have to become interstellar. But with approximations, you cannot become interstellar. You cannot become interstellar with a point that will take you all the way over here with a straight line when the actual event is taking place over here. When you're going 600 quadrillion miles, you can't make a mistake. You need precision. And that's what the math is about. These pieces predict the natural distribution of matter and the distribution of where you can find yourself in that space. The Titanic is headed to an iceberg over there with our numbers. If we don't make a change soon, we're going to crash as a species because our math needs to work in order for our science and our future to develop.
Terrance Howard takes on a new role as he challenges the fundamentals of orthodox mathematics. In this other perspective, he challenges us to reconsider long-held mathematical principles that we have always taken for granted. For example, why does 1 multiplied by 1 equal 1? Can we trust on infinite numbers formed by square roots? According to Howard, these fundamental mathematical principles may not be fully aligned with the governing laws of nature. Howard's critique goes beyond the academic setting, encouraging us to think beyond the constraints of standard mathematics. He feels that restrictions in our existing mathematical framework may be limiting scientific and technological progress. He invites us on a journey to discover the truth about mathematical procedures we've never dared to question. This is more than just a critique of mathematics. It's a chance to open up new possibilities by reevaluating the language we use to comprehend it. Terrance Howard investigates the link between mathematical principles and the physical rules that govern the universe. He emphasizes a fundamental mismatch between rigid mathematical concepts and the fluid dynamics of the natural world. This is especially visible in the principles of energy conservation and action-reaction rules in physics. In physics, the law of action and reaction assures that the natural world remains balanced and continuous. However, Howard suggests that many mathematical operations that we have undoubtedly accepted may not fully fit with these physical rules. For example, while multiplication, 1 times 1 equals 1, is simple in mathematics, it does not directly correspond to the subtle interactions seen in physics, where outcomes are dependent on several variables. Howard makes us think about whether our mathematical models are too simple to fully capture the complexity of the world by looking at this difference. This question goes beyond academia, influencing the tools we use to understand and manage the world. If the mathematics that drive science and engineering does not fully align with natural laws, it may hinder our ability to innovate and address future challenges. Howard's critique goes beyond criticism and calls for a mathematical revolution. If we rethink how we use mathematical ideas, it could lead to huge steps forward in technology, energy, and our understanding of the world. It encourages people with curious minds to not only learn math, but also to think critically about it and make it better so that our basic scientific language accurately describes how things work in the real world. Terrance Howard focuses his attention on the identity principle in mathematics, which states that everything multiplied by 1 remains itself, whereas anything multiplied by 0 results in 0. While this may look clear, Howard sees these laws as oversimplifications that do not correspond to the complicated processes found in nature and physics. For example, consider multiplying a seed by 1. In mathematics, you could anticipate to get 1 seed as a result. However, in nature, a single seed might grow into a tree and produce thousands of new seeds. In this case, the mathematical operation fails to express the natural process's inherent capacity for growth and multiplication. Similarly, multiplying by 0 in mathematics yields 0, suggesting total absence. However, in physics, nothingness is far more complicated, as even apparent emptiness contains energy and potential. Howard's critique encourages us to reconsider these fundamental principles, questioning whether they are too simplistic to correctly reflect the intricacies of the universe. For example, the identity principle may be effective in a classroom setting, but it is not enough when it is employed to explain the conservation of energy in a closed system. In such a system, energy cannot be created or destroyed, it can only be transformed. To investigate Howard's criticisms further, we look at the historical backdrop of mathematical conventions and their progression over time. Throughout history, there have been persons who dared to question established mathematical conventions, pushing the limits of accepted knowledge in search of deeper truths about the universe. One notable example is the controversy over the structure of the solar system during Galileo's lifetime. Initially, the widely recognized model was geocentric, based on mathematical calculations from that point in time. However, Galileo challenged this viewpoint with his observations and mathematical calculations, proposing for a heliocentric model. This transformation not only altered our vision, but also impacted how mathematics was utilized to comprehend the universe. Similarly, the emergence of non-Euclidean geometries in the 19th century called into question long-held beliefs about Euclidean geometry, which had been accepted as an absolute mathematical truth for generations. This finding opened up new paths for understanding space and prepared the way for Einstein's theory of relativity, which transformed our mathematical understanding of the cosmos. These historical examples highlight Howard's notion that mathematics is an ever-changing language that must adapt to better reflect the facts of the natural world and our understanding of them. By challenging accepted standards, we improve mathematics while preserving its continued viability as a tool for exploration and discovery. Howard's critique encourages us to follow in the footsteps of questioners and innovators, refusing to accept mathematical ideas at face value and instead engaging them critically. This technique is open to anyone who is curious about the world, not just expert mathematicians and scientists. By challenging ourselves to consider the concepts that underlie our understanding of the world, we can help to shape the evolution of mathematics, and as a result, our understanding of the universe itself. Terrance Howard's critique also includes an examination of economics and the financial system, putting insight on how mathematical concepts that can lead to real-world inequities. For example, when applied to financial systems, the seemingly simple equation 1 times 1 equals 1 takes on a new complexity. Consider the idea of interest in banking. The idea that money can expand over time through interest is based on mathematical calculations. However, Howard emphasizes that depending on how these formulas are applied, they can either benefit savers by increasing their wealth or cause borrowers to face substantial financial difficulty as a result of debt accumulation. Furthermore, Howard emphasizes the fluctuating value of money, which is profoundly anchored in mathematical economic models. A dollar's value now may differ from tomorrow due to sophisticated financial institutions and policies that, while theoretically valid, can contribute to inequity and economic instability. Howard challenges the mathematical basis of these institutions, encouraging us to consider the justice and sustainability of our financial structures. He encourages us to question if our current mathematical approaches to economics truly serve the greatest interests of society as a whole, or if they exacerbate inequality. In the quest of future discoveries, particularly in technology and space exploration, mathematical precision is not only useful, but also critical. Imagine launching a spacecraft with the goal of reaching another solar system or galaxy. If the estimates are even slightly off, the spaceship might miss the destination by thousands of miles. Terrance Howard's critique is particularly important in this context. According to Howard, our current understanding and application of mathematics may not be accurate enough for future challenges such as interplanetary travel. Consider the concept of navigating through space. Space is enormous, and the distances are so great that even tiny calculation errors could result in mission failure. Howard believes that in order for humanity to go beyond our planet's boundaries, our mathematical models must achieve a level of precision that currently exceeds our imagination. This precision encourages complicated mathematical concepts that are completely in line with the laws of physics. Furthermore, consider the evolution of new technology on Earth, such as renewable energy sources or medical advances. Each of these fields uses mathematical models to innovate and develop solutions that are safe, efficient, and sustainable. If the fundamental mathematics is wrong, it could hinder progress and result in inefficient, or worse, harmful solutions. Howard's point of view encourages us to think of mathematics as a dynamic tool that must evolve in order to meet humanity's future demands. By helping the next generation of scientists, engineers, and innovators get a deep understanding of mathematical concepts and how they can be used in real life, we give them the power to dream big and make their dreams come true.